Normalization. Normalization is the process of organizing data in tables to reduce data duplication, avoid anomalies. Anomalies mean errors. Keep data consistent. Normalization helps improve the database's efficiency, consistency, and accuracy. It makes it easier to manage and maintain the data and ensures that the database is adaptable to changing business needs. You can see student ID, student name, and lecturer are repeated. I rounded those things, right? You can see it. If John changes, we must update many rows, right? Using the normalization, we can fix these things. Why do we need normalization? Problems without normalization are equal to anomalies. Insertion anomalies occur when it is not possible to insert data into a database, the required fields are missing or the data incomplete. For an example, if a database requires that every record has a primary key but no value is provided for a particular record, right? It cannot be inserted into the database, right? The university wants to add a new course with course ID equal C3 and course name equal to AI, right? Can we insert this course without a student? No, because student ID and student name are required, right? But no student has enrolled yet. We haven't any third student, right? We are forced to insert fake or null student data. This problem is called insertion anomaly, right? Deletion anomalies. Deletion anomalies occur when deleting a record from a database and can result in the unintentional loss of data, right? For an example, if a database contains information about customers and orders, deleting a customer record may also delete all orders associated with that customer, right? Let's see an example. Wait. Suppose Nima drops the math course and we delete the corresponding row, right? We delete this row, right? Table like is this, right? But now Nima drops physics 2, right? If you delete that row. Now Nimal's entire record is gone, right? Even though you might still want to keep him as a student in the database, that's deletion anomaly, right? Updation anomalies. Notice here, the instructor for course is repeated for each student take it, right? See, Mr. Smith is repeating because of Alice and Bob take a math, right? Suppose the math instructor changes from Mr. Smith to Mr. Johnson, right? Right. We need to update all rows where course is equal to math, right? But I forget one row, right? Now the table has inconsistent data, right? I already forgot to update this row, right? This is an update anomaly because the same fact now has conflicting information, right? Let's talk about normal forms. Normal forms are rules of normalization, right? Let's talk about first normal form, right? A table is in first normal form if each cell has only one value, no multi-valued attributes. Each record can be uniquely identified, right? We can't keep multiple values in a cell, right? We can't keep like this, right? Okay. This is a cell, right? Right. This is the solution to the above table, right? We separate one course and include it in a new row with its details. We separate OOP and include it in to the new row, right? Now you can see one value per cell, right? Not multiple value. No repeating groups, right? Okay. 1 NF means no multiple values in one cell, right? We can't keep this, right? Okay. 1 NF removes multi-valued attributes like this, right? Okay. In 2NF, partial dependency happens when a non-key attribute depends on only part of a composite primary key. This only happens when primary key is composite, more than one column, right? See, look at the first table. It has student ID and course ID, right? It means we have composite primary key, right? Student ID and course ID, right? Student name depends only on student ID and course name depends only on course ID. These are partial dependencies, right? So, this is not in 2NF. Convert to 2NF. Split the table into two parts like this, right? Student table and course table, right? Okay. This table has no partial dependency. Table is 2NF, right? Simply remember 2NF means remove partial dependencies, right? Let's discuss about 3NF, right? Transitive dependency. A non-key attribute depends on another non-key attribute, right? But consider this, right? Okay. Primary key is employee ID, right? Dependencies, employee ID depend on employee name, employee ID and debt ID, debt name, right? Problem, department name depends on department ID. Name depend on department ID, right? So, employee ID, department ID and department name. This is transitive dependency, right? Split table to this, right? First one is employee ID, employee name and department ID because department ID depends on employee ID, right? And next table, department ID and department name, right? Transitive dependency removed. Table is now in 3NF, right? 3NF. 3NF removes transitive dependency. Right? Okay, that's it. If you get something from this video, don't forget to subscribe us, like, comment and share with your friends. Bye bye.